thank you all for being here. I'm actually super happy to be here. I missed last year's event in Madrid, courtesy of Air Canada, so I'm happy to be here with you. Now, joking aside, this video is a bit of a parody about how we do things, but it really talks a story about our industry and transitioning our industry from sort of traditional ways of doing things that are in nature more manual and more siloed in a way. So typically the way we ran our networks for the last 20, 30 years, right? You had manual procedures, CLI commands, some scripting, very vendor siloed islands of the network, and certainly different domains managed in a different way, so paradigms are different. And there's also a shift that is happening in the industry, going from more imperative way of programming the network, your CLI scripts, your API commands that are very prescriptive, to more declarative way of managing the networks through intent-based frameworks. And we, as a product unit, as a platform NSP, for those of you who have been working with us for many years, know that we've been investing a lot in a set of tools and capabilities that help our customers, yourselves, migrate those processes, right? Because it's not just about the tool itself, it's a change of a paradigm, it's a change of a procedure, sometimes even organizational changes, as Bruno talked about, right, that are required. So it's a bit of a journey to do this kind of transition from traditional ways of doing things to more modern, more automated ways of doing things. And automation in itself, I don't think anybody in this room would actually question the value of automation. We all know inherently that automation is good, but it's how do we get there, which areas do we focus on, and so on and so forth. So there have been studies, many studies now, that have attempted to quantify the benefits of automation, right? And often when we talk about automation, we first think about OpEx savings. Okay, so if you can save some cost, that's great. But it's not just about that. Very often the motivation for automation is actually in increasing or decreasing the time to revenue, right? Introducing new services faster, bringing those services to your customers faster, and therefore generating revenue faster. But one aspect that often gets overlooked is actually the other side of that coin, that deals with quality of experience. How fast can we troubleshoot the network? Any error in a network, problem occurs in a network, how quickly we can isolate it, how quickly we can resolve this. Automated tools are there to help improve those times, right? And there are studies, Analysis Mason did a study a year ago, but we also had some other studies directly from our customers who measure themselves. And we see tremendous improvements in those areas as well. So today's presentation is pretty short, so I will focus only on two topics, two parts of our portfolio: assurance and analytics and programmability. Now, assurance and analytics has always been an integral part of what we do. From day one, probably for the last 20 years, as an organization, we always thought that in management of IP networks, assurance plays a key role in helping close that loop with provisioning, right? So provisioning cannot be completely separate from understanding of what the real-time topology, state, and health of your network is. So we've invested and continue to invest in a number of different tools that help our customers better monitor and understand their network. So one such customer is a customer in Middle East. Actually, I think some of them are here in the audience. We've been working with them for a few years now, and they're using NSP as a single kind of assurance platform in their network. And that is a multi-vendor network, right? So they're using in IP domain Nokia routers and Cisco routers, and they're using NSP for assurance. Now, when we talk about assurance, it's not just alarms, right? Showing alarms on the screen, but it's also topology discovery and visualization of topology. It's inventory, it's performance monitoring, including OEM tests, or service assurance, right? So all of these different aspects on one single platform across multiple vendors. So crossing those vendor boundaries and vendor islands, kind of consolidating that way. And then the next step, what they're doing is they're extending this to what Bruno talked about, IP and optical set of use cases, so IP optical coordination to certain set of use cases that gives them that visibility across the layers, as well as the microwave domain that is also managed by a network services platform. So it's one example of using NSP as a full-fledged assurance and analytics platform. Now, speaking of analytics, actually here in Rome 5 years ago, we talked about the first introduction of AI and ML into NSP portfolio. Now, it's been a long time ago, when you think about it, 5 years have gone by. But at the time, we were focusing on some of the machine learning algorithms that help us make sense of large volumes of alarms and kind of arrive to the root causes faster. But since then, a lot has happened, and in particular, last November with the introduction of OpenAI and generative AI, large language models, there's a ton of excitement in the industry. And as you can imagine, we have been working on this topic for quite a few years now. And I would argue that AI and ML has its place in our industry, but in the end, our job is to deliver you the insights that help you make the right decisions about business decisions or network decisions in a timely manner. So we always pick the right tool for the right use case and have been developing that portfolio of capabilities in NSP that help address some of these use cases. So starting from I would say the simplest ones, right? The passive monitoring, reporting on past data and the current data in the form of reports, right? So for those of you who are familiar with the portfolio, we have analytics and reporting capabilities, many of which can be customized, custom reports, and those help quite a bit with some use cases. Then, oops, sorry, I've gone too far. Yep, I can go back. Then we move into the more advanced set of use cases on thresholding. There's for those use cases where we know the thresholds, we can program them almost statically. We can easily define those KPIs, and we can easily define thresholds and then trigger action from there. The next evolution then is, what about the cases where we don't know the exact thresholds? The cases where maybe there's some variability in the nature of the either traffic or signal or something, and maybe it's really hard to pinpoint what exactly the threshold should be. For those cases, baselining and anomaly detection are machine learning algorithms that help us then find those anomalies and trigger action. And obviously, the next step is venture into even more advanced things like outlier detection and predictions. So there's a large number of use cases actually here. And I'm not going to go through all of them. I'm just going to mention some of them. But the reality is, for the last many years, we have been developing some of them. They're already in the product. Some of them are right now being in the POC stages. You can see some of them in a demo room. We are trialing with some customers. And then a few of those are still under development and for future consideration. So let's take a look at a few of those. One is, I mentioned the thresholding. Now, the thresholding, for example, if you want to detect traffic black holing, it's a pretty straightforward thing, right? You monitor the ingress traffic, monitor the egress traffic, define a custom KPI, which is a feature of NSP, and then monitor that KPI, and then if it crosses certain threshold, create an alarm. Now, the nature of NSP is that such that any event in the system, or alarm, or any kind of other event, can trigger subsequent action. And that action can be, for example, a workflow that can then correct something or do a sequence of other actions, right? So it's closing the loop that is always available there. The second example is, as I said, a little bit more advanced. This is where machine learning comes into play. This example is in the wireless networks, right? In microwave networks, where we are monitoring the ratios of signal to power, and those vary based on the weather conditions and other aspects. So the system like NSP can train what normal is over a period of time, usually takes a couple of weeks, to do that. So once it determines the normal pattern, it will then be able to easily detect the anomaly from that normal, and again, trigger an action, trigger an event, which can result in a subsequent workflow or an action. Another yet more complex example is using the method of clustering. Now, this is the use case where we have to cluster the objects, in this case maybe ports or network elements, based on multiple variables, because not all are the same. Different chassis type, different releases, different number of slots filled, different traffic running over those nodes or over those ports will result in different behavior, and therefore the system like clustering can start categorizing them in different clusters and determining what is normal for that group of ports, for example, right? So let's take a look at this example. This is the list of use cases we developed for this customer, and here you can see the bad packet received use case. Of course, in order to define any one of these ML use cases, you need to define what the data sets are that you're working on, in this case, ports, telemetry that you're collecting, and then we say, okay, now let's execute this particular use case. So what you see here is a graph that shows speeds on the vertical axis and received bad packets on a horizontal axis. And the system has determined that for one reason or another, the ones on the left-hand side are considered normal. There are some bad packets, but the ratio of those bad packets to the speeds is not abnormal. But the ones on the right-hand side are suspicious. And the speeds are pretty low, but the number of bad packets is pretty high. So we can then dive into one of those and say, okay, let's take a look at what's happening here. And you will see that there has been a steady state of received bad packets throughout the month of May, with the combination here on May 11th, right? And then, of course, that can trigger subsequent action, and obviously you may want to take a look at these things. And then next natural step is evolution into more predictive set of use cases that are coming after this. The next area, when it comes to visualizing all of this, is dashboards that we are changing and adding quite a few capabilities to our system. For many of you know, we've been investing in user experience quite a bit in the last probably 7-8 years, right? Laura and the team are here. They're working with you consistently to try to get feedback and continuously enhance the usability, accessibility, and efficiency of our UI. So dashboards are that next improvement, where we are adding new landing pages for operator when they log in, where they can see the health of the network, health of the services at a glance. They can also see, of course, the topology of the network, as well as the inventory of the network. The new menus have been derived, and thank you, all of you who have participated in the tree testing for this. This is based on your feedback, structuring the menus in a way that is most efficient for accessing the capabilities of NSP. And then, of course, seeing the health of services, going to service supervision, and being able to create new services from there. The other thing that we also have added is the ability to personalize and customize those dashboards. All of us, when we use any feature-rich products, we like to customize it. We like to make it so that it really works for us, and that's what NSP does. It allows operators to customize these dashboards and make them personalized for each of the operators. The next topic I would like to cover is the topic of programmability. Years ago, we learned that every network is somewhat unique. We build the products that are generic, that service 1,000 customers, and yet every service, every network is somewhat unique in your day-to-day life. So we need to marry those two things, right? And as a product unit, we do it through building a set of capabilities that exist in a product, like those that you've seen on a UI, but that can be customized. I've talked about customization of dashboards, of custom reports, and things like custom KPIs and things like that. But under the hood, we also can customize NSP behavior through the set of programmable frameworks that allow us to modify existing behavior or add new ones based on your needs. So what are those? So we are talking specifically about intent engine and intent framework for definition of any kind of intents, whether it's a device intents, configuration intents, or service intents. We are talking about workflows that can be written runtime, and we are talking about adapters that are focusing more on adaptation into the network. All of these artifacts can be added runtime. You don't need to upgrade NSP release in order to support any new artifact, which is, I think, a really, really important characteristic of it. And all of them can be written either by our engineers or by yourselves, right? Because we don't want to create this dependency on our professional services. Some of you have very capable engineering teams, and in those cases, you are more than able to do things yourself. So the way it works is intents, as I said, are the object models that are exposed either through UI or through APIs to your OSSs. Those intents could be, let's say, service intent. Service intents come packaged with NSP, but some parameters may be not to exactly the ones that you want for your OSSs. Maybe something needs to be modified and added, so that can be done by modification or addition of new intents. Similarly, for workflows, workflows are very often used to sequence set of actions that need to be executed that are specific to your MOPS, right? I'll give you an example, a simple network element upgrade, which consists of very few steps. You download the image of the network to the network element, and you flip over to the new image. But when you look at the real network element upgrades and you talk to Paul, who is doing a demo of it, you will see that there's a long list of things that you need to do as a pre-checks, as post-checks, validations, and all of these steps will really be specific to your network, so it better be written for your needs, for your MOPS. And then adapters are our way of adapting quickly to the device-specific configurations of any vendor for any object model, and translating that into not-bound expressed intents or common models that exist in NSP. So to do all that, I'm super happy to announce that we are providing an SDK so that you can develop your own adapters as well as our engineers can, right? So we use this SDK internally. Our professional services team is using the SDK, or you can start using it yourselves. And it is integrated with the Git repo. It can be integrated into your own CI/CD pipeline and help you really with that kind of full deployment of artifacts into the network. The last part that I wanted to mention here is that we are adding the extensions to VS Code to help accelerate development of some of these artifacts, workflows and intents in particular. And again, you can see those examples, and for those of you who attended Sven's session yesterday, you would have seen some of that. And VS Code extensions are a very good example of how to quickly get started with the development of some of these artifacts. And you can imagine, we talked a lot about ChatGPT. You can imagine that as a very next step, it's a perfect use case for use of Copilot-like tools to help accelerate the development of these kinds of artifacts. So you will see that VS Code extensions are available now for workflows. In a few months, we will have the intents ready, and the adapters are coming next. So there's a lot more to talk about. I just wanted to encourage you all to spend some time with the automation demos. There's a ton of them there. We are talking about intent-based service fulfillment, large-scale operations, pushing those intent-driven configurations to networks of thousands of elements. IP optical that Bruno and Jelena talked about. Transport slicing demos, analytics assurance demos, and ton more demos. So please spend some time with our experts there. They're happy to engage with you and explain in a lot more detail about this topic. So in summary, we are working effortlessly. We are working really, for the last 20 years as a team, we are working to bring you the set of tools, capabilities that help you move along this journey towards automation, right? And we are using the best tools available for us, best technologies, including AI and ML, to bring that kind of flexible, programmable automation platform to you and to help you achieve your goals and your objectives. So with that, I want to thank you for your time and wish you a wonderful rest of the event. Thank you.